Alright students, today we are going to look at how to solve systems of linear inequalities. Just like systems of linear equations, these are two or more inequalities in one problem. So, first thing you want to do is make sure that the first equation or both equations have the y by itself. So this one is good to go. This one here, all we have to do is divide by -2, divide by -2, and you get y is, remember, when you divide by negative, your inequality will be switched, and so you get -1/2 x. So now that the y's are isolated, I can go to the graph and plot these two inequalities. So this is the x, and this is the y axis. So let's start with the first one, -3. So the y-intercept is -3 right here. Slope is 4, so you go up 1, 2, 3, 4, and over 1. So you have your first inequality here, and we know this inequality has to be a solid line. Why? Because it's equal to or less than. Remember, if it's less than, we have to shade below the line. Okay? Now let's go to the other inequality, and this one is y is less than -1/2 x plus 0. There's no y-intercept here, but we know that it's 0. So we go to 0, and we know that the slope is -1/2. So down 1 unit over 1, 2. So we have a line that we know has to be dotted. Alright, so let's make this line dotted. It's a dotted line, and we know we have to shade below. See this right here? Less than, so we have to shade below. And so the solution to this system of linear inequalities is basically the area where both shaded regions overlap. So this will be the solution to both inequalities. That's where both shaded regions are overlapping. So this is your solution to this system of linear inequalities. Okay, I hope that makes sense. Sometimes you will have more than one linear inequality. So, for example, I may have 2, I may have 3, I may have 4, and just remember that the solution will be the portion where all shaded regions overlap. So if I have something like this, y is less than 1/3 x plus 2, y is greater than x, y is less than or equal to 1. So I have 3 different inequalities. The nice part about this is that the y's are isolated. So let's go to the graph. And if I graph the first one, if you notice the y-intercept is 2, so that's 2. Slope is 1/3, so you go up 1, 2, my bad. You go up 1 and over 1, 2, 3. So up 1 over 1, 2, 3. So I have this line here, And notice it's less than or equal to, so we know it's a solid line, it's solid. And we know it's going to be, we have to shade below, all right? So below that. Let's go to the second one here. The second one is y is greater than x. There's no intercept here, y-intercept, so we know it's going to be 0. So 0. Slope is 1, so up 1 over 1. And there's my line. And recall that this line has to be dotted because it's greater than x. It's not equal to. So let's make this line dotted. All right, dotted line, and we have to shade above. It's more than, so you shade above this line. And the last one is, well, it's just y is less than or equal to 1. So there's no x here, it's just a number. So we know it's going to be a horizontal line right at 1. Well, that's 2. Let's bring this down just a bit. Right at 1, right there. Let's make it a different color. Let's make it orange. And we also know that this line has to be solid because it's less than or equal to. And we have to shade below. So if you notice carefully here, the 3 shaded regions meet right about here. So anywhere here would be a solution. So any point here, let's say a point here could be -2, 0. -2, 0 would be a solution to the 3 systems of inequality. So any point in the shaded region that I had here where they overlap is a point of solution. The entire lesson is basically dealing with graphing systems of linear inequalities, and wherever the shades overlap, that will be your solution. I hope this makes sense. Please let me know if you have any questions, and I'll see you guys very, very soon.